Alright, what I'm going to do with this video is I'll do about half of the review with you. For most cases there are 2 problems of each type, so if we do number 6 together you should be able to work out number 7 using my example as a model, and same thing for 8, and if I do 10 you should be able to handle 11 using my example. And in a couple instances where there's only one problem, I'll either get you started or sort of leave you to work on your own. So we'll see. Here, the first one, we've been given a couple of linear factors and we want to know what the roots are. So we're going to set each factor equal to 0. 3x minus 2 equals 0, and we'll solve that one for x. And then we also have x plus 5 equals 0, and we'll solve that one for x. In many instances it's mental math. I'll go ahead and work it out. Subtract 5 from both sides. One of our roots is x equals negative 5. And here if I add 2 to both sides and then divide both sides by 3, I've got my 2 roots here. And then number 3, very much the same. It might help to rewrite the problem like this. Your inclination might be to distribute, but I've already given you the linear factors. So your job is just to set each linear factor equal to 0 and solve. There's the first linear factor, set equal to 0 and solved. So one of our roots is x equals 0. And then for the other one, set the linear factor equal to 0, add 9 and then divide by 3, and we're going to get x equals 3 for the other root. So there are the 2 roots, x equals 0 and x equals 3. So we've got a quadratic here. We've been given its linear factors. We want to know the roots and the vertex. So we're going to find the roots in just the same way as 1 through 4. Set each linear factor equal to 0 and then solve for x. In this case, I would just add x to both sides to get x equals 3 for one of my roots. And then maybe it's kind of easy to see that that's negative 2. But when you have little details in here like a negative in front of the x or a 2x plus 5, it can really help to use this strategy of set the root or set the linear factor equal to 0 and then solve for x. That way there's no guesswork involved. The method for the vertex here, the opposite of b over 2a, that's going to give us the x-coordinate of the vertex. B is 1, A is negative 1, so that's 1 over 2 times negative 1, which equals positive 1/2. So there's the coordinate, or the equation of the axes of symmetry, x equals 1/2, which is the same as the x-coordinate of the vertex. And now we can evaluate the function at 1/2. To get our final answer. That's negative 1/4 plus 1/2 plus 6. These two come together to be positive 1/4. So that's 6 1/4 or 6.25. So then our vertex is going to be 1/2, 6.25, and I think that would be 37/4 if we wrote it as a fraction. But that number is the same as 6.25 or 6 1/4. So use this identity, opposite b over 2a, a, b, and c, to find the x-coordinate of the vertex, and then evaluate the function at the x-coordinate to find the y-coordinate of the vertex. Or, go to your TI graphing calculator, put your function into y equals, have a look at the graph, and then use the calculation features to find the maximum, left bound, right bound, guess. Lo and behold, the calculator won't always get it exact, but it'll get pretty close. You round that up to 0.5, and here 6.25, just like we thought. You can do the same thing to find the roots. Second trace, 0, left bound, so you go to the left and press enter. Right bound, go to the right of the root and press enter, and then guess, and there's one of our roots, -2, 0, and you could repeat the process for the other root. The left bound of this root, enter. The right bound, enter. The guess, enter. And then there's our other 0. So I've given you instructions right here. Set equal to 0. Okay? 0 equals x squared minus 10,000. Isolate the squared variable. Okay? Well, to do that, I'm going to add 10,000 to both sides. 10,000 equals x squared. Square root both sides. So that means x equals plus or minus 100. And you should notice, or maybe recognize that as the difference of two squares. And you would really solve this one in the exact same manner. Here the question is to determine what you must add to both sides in order to complete the square. And then I've explained the method. Divide b by 2 and square the result. So here b is -7. So let's square that result, and that'll be what we add to both sides. -7 over 2 squared, that's going to be 49 over 4. So to complete the square, I would add 49/4 to both sides. b is -9, so divide by 2, square it, and that's what you add to both sides. Be sure you square the numerator and denominator. And then here we're asking you to go ahead and finish the process of completing the square. Half of 12 is 6. 6 squared is 36. So how do I turn a -5 into a 36? I add 41 to both sides. Now I've got x squared plus 12x plus 36 equals 41. This can be written as a perfect square. X plus 6 squared equals 41. Square root both sides to get x plus 6 equals plus or minus the square root of 41. Subtract the 6, and those are your two roots right there. -6 plus or minus the square root of 41. Half of b squared. So over here, half of b would be 3. 3 squared is 9. So how do I turn a 1 into a positive 9? And that's the number that I would add to both sides. Alrighty. So I'll give you a hint here, starting out on the tile model. We know we're going to have 2x squareds, so those are the big boxes. And then we need to arrange the 7x and the plus 5 in such a way that we make a rectangle. If you start drawing stuff that doesn't make a rectangle, you're going to have a bad time. So there are two of my x's. And you can try different patterns, and here's where having the tiles to move around probably would be helpful. There's a third x, there's a fourth x, there's a fifth x. I need 7x total, and I need space for 5 units. So the tile model would look like this. And then you need to determine what the linear factors are given the picture. I'll go ahead and finish it for you. X plus 1, 1, 2x, plus 1, 2, 3, 4, 5. Those are your linear factors. You should be able to go find the roots given those using the strategy from the previous pages. Okay, here we have the quadratic formula problems. A, B, and C are kind of unfriendly values when considered all together. So our formula is the opposite of B, plus or minus the square root of b squared minus 4ac, all divided by 2a. And now I'm just going to plug in a, which is negative 9, b, which is 5, and c, which is 10. Negative 5 plus or minus the square root of 5 squared minus 4 times negative 9 times 10, all divided by 2 times negative 9. And then you could simplify that. Let's see, this would be 360, I think, yeah. Be 25 plus 360. So negative 5 plus or minus the root of 385 over negative 18. And then the question is, does 385 simplify in any way, shape, or form? So 385 and 5 would be, let's just use the calculator. 77. And 77 is 7 and 11. So the prime factorization of 385 is 5, 7, and 11. There are no doubled up primes, so there are no perfect squares hidden inside 385. So that is your final answer for x right there. You could maybe do some simplifying. Negative divided by negative is positive, so you could simplify those. And then negative divided by negative is positive, but negative divided by positive is negative. So the plus minus sign, it doesn't really change anything when you divide by negative. The positive becomes negative, the negative becomes positive, but the result is you still have a plus minus root 385. So this part right here is really probably the most important part, is being able to properly plug things in. And then the rest is just order of operations to simplify. We did this in class today. And this part I really want to leave up to you to write your own explanations. But in case you don't have a graphing calculator at home, I can put these in for you here so you can draw a conclusion on your own. Oh, and that should be, let's call that a typo right there. I was trying to stay consistent. That should be a minus 12x. Alrighty, and then if we graph those, what we end up with is a situation where the roots, well, I'll zoom in. And this is what we're noticing here, is we've got 4 different quadratics, and the roots are always the same on these 4 quadratics, but our vertex keeps shifting depending on if we've doubled the original or quadrupled or tripled the original quadratic. So same roots, different vertex there. I hope you find that helpful. We'll do more review tomorrow in class and take the test on Wednesday.